Welcome back. In the previous lesson, you installed a compiler, wrote your first program, and built it from the command line. That's the foundation. Now, we're going to set up a proper development environment, an IDE, so you can compile, run, and debug C++ comfortably. There are 3 common paths, and the right one depends on your platform and preferences. By the end of this lesson, you'll have a working editor with debugging, and you'll know how to verify that everything is configured correctly. Let's get started. There are 3 main paths for setting up a C++ development environment. Visual Studio Code, a lightweight editor plus extensions. It's the most flexible option and works on every platform. If you're not sure where to start, this is a good default. Visual Studio, the full Windows IDE from Microsoft. It comes with a strong debugger and project integration built in. If you're on Windows and want the most integrated beginner experience, this is the path of least resistance. And CLion, a full IDE from JetBrains with excellent CMake support and cross-platform workflows. It's especially useful once your projects grow beyond single-file programs. All 3 will get you there. Pick the one that matches your platform and comfort level. To set up Visual Studio Code for C++, you need 4 things. First, VS Code itself. Download it from code.visualstudio.com. Second, a working compiler. If you're on Linux, that's GCC. On macOS, Clang comes with Xcode command line tools. On Windows, install Visual Studio Community with the C++ workload to get MSVC. Third, the Microsoft C++ extension. This gives you syntax highlighting, IntelliSense, and debugging support. Install it from the Extensions panel inside VS Code. Fourth, optionally, the CMake Tools extension. You won't need this right away, but it becomes valuable once you move to multi-file projects with CMake. With these 4 pieces in place, VS Code is ready for C++ development. Here's the basic workflow once VS Code is set up. Step 1. Open your project folder. Use File, Open Folder, and point it at the directory containing your source files. Step 2. Create a file called main.cpp. Step 3. Compile from the integrated terminal. Open the terminal with Control backtick and use the same compile commands you learned in the Getting Started lesson. G++ or CL with your warning flags and the -G flag for debug symbols. Step 4. Add a launch configuration later when you want debugging from the editor. For now, the terminal workflow is enough. The key insight is that VS Code starts as a text editor, and you gradually add IDE features as you need them. If you're on Windows and want the most integrated experience, Visual Studio is the straightforward choice. Step 1. Install Visual Studio Community. It's free. Step 2. During installation, select the desktop development with C++ workload. This installs the MSVC compiler, the debugger, libraries, and project templates all at once. Step 3. Create a new console app project. Visual Studio generates a starter file and a project configuration for you. Step 4. Build and run with the built-in debugger. Press F5 to compile and launch under the debugger, or Control F5 to run without debugging. The reason Visual Studio works well for beginners is that the compiler and debugger are fully integrated. You don't need to configure paths, install extensions, or write launch configurations. Project templates remove the setup friction that trips people up in lighter editors. CLion is a full IDE from JetBrains, and it's the strongest option if you want your workflow centered around CMake. Here's the typical path. Step 1. Install CLion. It requires a license, but JetBrains offers free educational licenses. Step 2. Point it at a compiler toolchain, GCC, CLang, or MSVC. CLion will auto-detect most installations. Step 3. Open or create a CMake project. CLion uses cmakelists.txt as its project file, which means your build configuration is portable across platforms. Step 4. Let the IDE generate and manage build directories automatically. CLion is especially useful once your projects are no longer single-file programs and you want clean separation between source and build artifacts. If you're just starting out with single-file exercises, VS Code or Visual Studio may be simpler. But once you move to multi-file CMake projects, CLion really shines. This is the moment your editor becomes a real development environment. Here's the debugging loop you want working as soon as possible. Step 1. Build with debug symbols. That's the -G flag for GCC and CLang, or the /ZI flag for MSVC. Step 2. Set a breakpoint. Click in the gutter to the left of a line number inside main. A red dot appears. Step 3. Start debugging from the Run and Debug panel in the sidebar. Step 4. When execution pauses at your breakpoint, inspect variables in the side panel. You can see their current values. Step 5. Step over one line at a time using the toolbar or F10. Watch how the variables change with each step. If this loop works, build, break, inspect, step. Your editor has moved beyond syntax coloring. It's now a real development environment. Hello World is fine for testing compilation, but it's a poor test for debugging. There's nothing to inspect. No loop, no changing state. Here's a better program for testing your debugger. We include IOStream and vector. We create a vector of integers with values 1, 2, 3. We declare a total variable initialized to 0. Then we loop through the values, adding each one to total. Finally, we print the result. Set a breakpoint on the line inside the for loop, the line that updates total. Step through each iteration and watch total change from 0 to 1, then to 3, then to 6. If you can see those values updating in the debugger's variable panel, your setup is working correctly. This gives you a loop, a container, and a changing variable. Everything you need to verify that debugging actually works. No matter which editor or IDE you choose, there are 4 debugging skills you need immediately. First, set a breakpoint. This tells the debugger to pause execution at a specific line. In every IDE, you click in the gutter next to the line number. Second, inspect variables. When execution pauses, the debugger shows you the current value of every variable in scope. This is how you understand what your program is actually doing versus what you think it's doing. Third, step over and step into. Step over executes the current line and moves to the next one. Step into follows a function call down into its implementation. Fourth, rerun after rebuilding. Make a change, recompile, and run under the debugger again. These 4 skills work identically in VS Code, Visual Studio, and CLion. Master them once, and they transfer everywhere. Before you start writing real exercises, establish 4 habits. First, enable warnings at a strict level. -wall-wextra for GCC and CLang, or /w4 for MSVC. Warnings catch bugs before you run the program. Second, always build debug configurations with symbols. That means the -G flag. Without it, your debugger can't show you source lines or variable values. Third, keep generated files in a build directory. Object files, executables, anything the compiler produces. It all goes in build, not mixed in with your source code. Fourth, use one project folder per exercise or small app until you understand the layout. Now, the folder structure. At the top level, your project directory. Inside it, src for your source files, include for headers, build for compiled output, and a cmakelists.txt if you're using CMake. This layout works in every IDE and scales as projects grow. Let's talk about the 4 setup problems that trip up almost every beginner. Problem 1. The editor can't find headers. You include IO stream or vector, and the editor underlines it in red. This usually means the compiler path, include path, or project configuration is incomplete. Make sure your IDE knows where the compiler is installed. Problem 2. The code runs in the terminal but not in the debugger. This means your launch configuration is wrong. Check 3 things. The executable path points at the latest built binary. The working directory is correct, and the debug build actually includes symbols. Problem 3. IntelliSense or code completion is wrong. This happens when the editor isn't using the same compiler flags and include paths as the real build. Sync your editor configuration with your actual compile command. Problem 4. Build output is mixed into source folders. Object files and executables landing next to your .cpp files. Move everything into a dedicated build directory early before it becomes a habit. Your IDE is configured. Before moving on, verify your setup with this 5-point checklist. 1. Compile from the integrated terminal. 2. Run the executable from the integrated terminal. 3. Start a debug session. 4. Hit a breakpoint. 5. Inspect variables. If all 5 work, your setup is ready for real exercises, not just editor experimentation. Now, what to learn next? The IDE helps you work faster, but the language fundamentals and build model still matter more than editor features. Continue with types and I/O to learn about variables, strings, and input-output. Then, control flow and functions for conditionals, loops, and function design. Then, build and debug to deepen your understanding of the compilation pipeline. Setup is done. The real learning starts now. Thank you.